My name is Silas Olson, and this is Additive Revolutionaries. So, the problem statement. This guy, he's a mechanical engineer. His name's Adam. He says that 3D printing is great, but it's limiting with what materials you can use. Engineers today are very much limited by the use of but the use of 3D printing and what they can do with it. Currently, it's pretty much just plastics. Some engineers want to be able to do more because engineering is really, really looking for new ways of manufacturing. One of those is possibly 3D printing, but we can't quite do that without something better than plastic. So my solution is to create something that can print in metal. So here is the structure for it so far. This is still going through design review, but this is the basic so far. We got the structure with the nozzle where the metal will come out. We have a presser that will form it in a correct way, and then a cold air that will solidify it afterwards. So as for competitors, we've got the normal PLA 3D printer. These go for a bit cheaper. However, they can't print in metal, of course. They're very quick, but not autonomous for the most part. Manufacturing methods is pretty much our typical day-to-day how we make metal now as engineers. This is really expensive and very costing as well as time costing. So yes, it can do metal, but it's not quick and it is not autonomous. We train entire teams for this. We often take entire months to get back. There's also resin 3D printers, which are the same issue as PLA, where they are quick and they can be autonomous sometimes, but they only print in a type of plastic, which is called resin. They don't print in anything better than that. So projected ARR, it's going to be $10,000 per printer. The plan is to produce the first for local customers. That way we can build this idea up in the valley, especially since Arizona is headed up there with a lot of their technology that's growing up in the valley and Mesa, Tempe area. The technology will take probably about 5 years to research and refine. By 2032, the technology will be refined especially after testing with all these customers, we'll be able to mass produce. So this should cause a jump in marketing in the 2033 until it stabilizes in 2034. Purchases will be one time in person to make sure each customer gets the care they need for their printer. These are going to be really, really helpful for them. So we want to make sure that they are modified to suit each customer the best. So we're going to start with local small businesses around Arizona. After that, we'll move to broader Arizona manufacturing companies with the hopes of just growing the technology more and more until eventually becomes mature enough and well known enough that we can move on to bigger places like Tesla, SpaceX. These places can definitely use some sort of metal 3D printing in their workshops because that's going to help and save a lot of time, a lot of money for these companies. So for my team, I've got Jeff Olson. He's a software engineer. He has 20 plus years in the industry of coding engineering management. He is going to help a ton with the management of all the engineers that maybe will come down the line. He also has a ton of experience in coding, and that will be really useful for G code or different things that we have to use on our 3D printers. I also have Faith Vandenberg on my team. She is a marketing strategist and physics expert. She has extensive experience in physics needed to analyze thermal energy and material sciences behind the printing, especially since in the research, we're going to be using a lot of thermal power to heat up that metal, and we want to know the best ways of doing that, best ways of causing a really good heat gradient, and just getting it the most efficient it can be. So our current status is in March. This is going to be an initial questionnaire for people. That's been this month pretty much, and that has gone well. In April, we're asking for $25,000 for startup research. This is going to help a ton just with being able to research this issue and see what best ways we can do this with. And then in October, we have public launch. So we want people in the Valley, especially, to know what is happening. That way they can get involved if they want to. My goals, one is to research to be complete by September, at least with the basic project. So we want to be able to have something that we're starting to build by then. even if it's still maturing, because it's still going to take 5 years for the technology to be fully matured. But we want to at least start prototyping by September. Uh, so goal number two will allow 5 years for growth of the technology. And goal number three is that we want to have 2 to 3 times growth within the next 7 years. I think that should be realistic, especially with how pressing this will be and how helpful this will be to manufacturers and engineers. So the use of funds are mainly going to go into research. That'll be the biggest thing. Some will go to marketing as well, of course, and then to design and implementation. So I want to make sure that we can actually build these things and get them into the hands of our customers. So in exiting, here's another engineer, and he says production will be faster than ever. AI may be the new hype, but manufacturing will never be replaced. AI and all these other technologies, they're out there, they're growing, and they're growing fast. But manufacturing is always going to be a need. We're always going to need to build, and we need to find new ways to do that too, not just focus on the software side of it. And that's my presentation. Thank you.